All-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and freedomslips.com, its staff, or affiliates. You're listening to Revolution Radio, freedomslips.com, 100% listener-supported radio, and now we return you to your host.
Ladies and gentlemen, welcome back with another episode of Cosmic Catastrophe on Revolution.radio. I am your host, Diamond, from the Oppenheimer Ranch Project. And joining us, as usual today, is my lovely partner and co-host, Leah Shaper.
Hello.
Welcome to the show. We have a great program set up for you today in two parts. Some of you may know that a volcano in Indonesia has been exploding over the last few days. The name of it is Lewotobi. So we'll discuss that volcano and some of the implications of what volcanic eruptions do and how they can affect our climate. We'll touch on Tambora and Hunga Tonga, and we may have some explanations for you. We'll also discuss the VeI scale. So it will be a general discussion on large volcanic eruptions. These two last explosions from Lewotobi are some of the biggest eruptions since Hunga Tonga. And so we'll get into that. Second half, we're going to talk about the Kessler syndrome. I just realized I forgot to bring up the article on the space station, and they're going to drag it and re-enter it in a few years here. Mm-hmm. But in the meantime, we'll talk about the Kessler syndrome and some of the implications of that, because every single year, hundreds of more objects are being shot into low Earth orbit, and that could mean a very dangerous situation.
Indeed. In fact, it has created some danger already.
Do you have some statistics?
No, I don't.
Okay.
I'm just
I think I may have
what
some.
I read earlier today about specific incidences of collisions, etc.
Let me pull this up. This is the first eruption of Lewotobi about 72 hours ago. Coming in at just VeI2, these are short eruptions. So we'll get to the scale. In order to have a VeI5 or larger eruption, you need an eruption like the one you're looking at here to occur for 24 hours straight or something like that, in order to get the amount of material you need to jump up in scale. These eruptions here at Lewotobi are only lasting short periods, a few hours, if that, which means a lot less material is ejected, even though it goes up high.
Yeah, that's interesting, because I was just reading earlier, I guess the first major eruption here reached 10 kilometers. And so if you go plug that into the Googler, it'll tell you that something that reaches 10 kilometers, 10 to 25 kilometers is a VeI4. But really, it's based on the amount of material that's ejected.
Yeah, went to 55,000 feet after it exploded on the first pass. It was first reported to around 42,000, then 52,000. Then the final call as far as aviation was 55,000 for the ash. That is up and into even though we're equatorial here, that is right near the stratospheric boundary. So what's getting pushed up there are sulfates and aerosols, not water. Mm-hmm. So Hunga Tonga is a different type of major eruption with completely different effects. So what this volcano is doing is pushing a little bit of stratospheric aerosols up there that will last a few years.
Yeah.
And we don't know if it's over. So just about 24 hours later, last night, it blew up again. This one's saying an ash column rising to 9,000 meters above the summit. But how high is the summit? Therein lies the question.
Oh, I did see that somewhere.
But I can just come over to the latest volcanic ash advisory here, and we can see how high that went.
The height of the volcano is 1,584 meters, 5,197 feet.
1,970 feet? Yeah, so times 9,000 meters. I did see an update. There it is, 52,000 feet on this one. Yeah. So just slightly less. And the initial blast killed up to 10 people. And because of that, they went in and evacuated everyone in this populated area. 16,000 people were evacuated. in and around Mount Lewotobi, Laki. This is in Flores, Indonesia. And we've got some interesting stats. So first of all, it was difficult to get these people out. I don't know if they all got out because the amount of ash on the roads in the hardest hit areas was feet thick. So first you got to plow that stuff. It's not like you can just drive through volcanic ash.
I thought I read that they only evacuated like 6,500 people out of that 16,000, but don't quote me on that because
Maybe that's all they could get to.
It could be. I don't see if I can find that.
Yeah, this article
they did plan to evacuate 16,000 residents. So maybe I'm misremembering.
So as of today, no additional casualties were reported on Saturday, but the authorities have raised Lewotobi Laki's alert status to the highest. That would be red with an aviation color code red, meaning there's no flights around here. Because if one should happen in a plane were to be up there, it would be the end of everyone in the plane.
Yeah.
Experts were examining the affected area before the second blast on Friday, and they found craters up to 43 feet wide and 16 feet deep. Think about that. That's the depth of a 2-story building and the width of a parking lot.
Yeah.
So these are gigantic rocks that are hurtling back to Earth. I can't believe the death toll wasn't higher.
Yeah, that's amazing. I mean, especially considering you have a lot of crushed buildings from this too.
Yeah, and some of the deaths were from even further away, from hot, smaller embers igniting the roof, and then people burn alive.
Right.
So just a tragedy all around, but and no way to know if it's over. This is an ongoing eruption. The alert level has been raised now to red. And here it says authorities have urged thousands of evacuees to stay clear of the danger zone as the government prepares to relocate 16,000 residents. And the impact so far this week is 10,000 people across 14 villages.
Do you know, so for stratovolcanoes, is it typically that the first eruptions are the biggest, or does it sometimes happen that you get bigger eruptions later in the process?
Well, stratovolcano is the most typical type, but they all display different characteristics.
Mm-hmm.
But each volcano maintains the type of characteristics it has. Does that make sense?
Yeah.
So this volcano consistently erupts VEI 1 and 2 with really no major paroxysms. You see a VEI 3 here back in 1932.
Mm-hmm.
That was a 5-day eruption. But the current state of eruption has been ongoing now for over a year and is still only at VEI 2. This, I think, may push it up to VEI 3. Did I say that initially?
No.
Okay, so this might now be at VEI 3, which is not a big eruption. So you really need to wrap your head around the scale here. From VEI 0 to VEI 3, they're relatively small eruptions, even though they may look big. So this single incident, these two blasts, is not even VEI 2, is probably right around VEI 2, and it went up into the stratosphere, for goodness sakes.
Well, I mean, and that's just it, right? Like, if we're talking about magnitude, you can sort of talk about it in several different ways. You can talk about the height that it reaches, how, so therefore sulfates reaching the stratosphere and that potentially having a climactic effect globally because it is equatorial for the most part. But it's not, but also the amount of material is going to have an impact there. So
yeah, so hopefully what we can glean is there's a huge problem with the VEI scale just from this chart, because they're showing a VEI 2 goes to 5 kilometers here, right? And in order to get up to where we are, you need a VEI 7, which is not correct. What is correct is the volume of material is correct, which puts it in the VEI 2 category, which means you can disregard the height.
Except that this was 10 kilometers, so it would be more like a VEI 4.
10 kilometers.
Rather than a 7.
What?
The height that the eruption on, I think on Thursday, was 10 kilometers.
Yeah, but but it's not a VEI4. That's the point I'm making.
Right.
Yeah, so you can't go on height alone. If it looks big, it may be scary. You get this big, scary eruption, but we're not going to have a year without a summer. And here is the scale I'm talking about. Even if it was VEI3, VEI5 doesn't cause a year without a summer. You need VEI7.
Yes.
So just to get from VEI3 to VEI5, it's 1,000 times bigger eruption.
Yeah.
So to get from VEI5, I mean, think about it. You need 100,000 times bigger eruption to get a year without a summer.
Mm-hmm.
So that's going to be a big boom.
Yeah.
Now, what the smaller eruptions do, like you said, the ones that make it to the stratosphere, it doesn't matter how big they are. They're even VEI5s. Maybe even this one could affect temperature. And it's a short swing in temperature, usually just a year, and it drops it down noticeably. Here we see Agong, El Chicon, and Pinatubo.
Right. Well, it drops it down noticeably on a graph, right? But the appreciable effects that we actually feel and notice may be a lot smaller in reality.
And
right, because the trend of that line is still consistent despite the drop.
And in some areas, much larger, like the Tambora eruption that caused the year without a summer, even though it only shows a 1 degree C cooling, in places like Europe, they averaged 10 degrees below normal for a year and a half.
Right.
And that has to do with the fact that Tambora was a stratospheric aerosol injection eruption, not water vapor, and it literally darkened the skies, reflected the sun, and in some areas made it much colder than what this graph is alluding to.
Mm-hmm. So we have several different things coming into play that determine effects, right? It's the volume of material, it's the height of the eruptions, but it's also the chemical composition of the eruptions.
Exactly. So the 1815 eruption of Mount Tambora was called VEI7. You froze up. Can you still hear me? Wow, I've lost you completely. Well, I'll continue to talk. Okay. So the 1815 eruption of Mount Tambora was VEI7, which is going to be thousands of times greater than the eruption we just witnessed, the Lewotobi, and it barely did anything. It affected the weather for a few years. Now, because of the way the situation was, it killed many people. It killed many people in Indonesia because of the amount of ejecta. I'm sure there were probably tsunamis that washed up on neighboring islands from the huge pyroclastic flows, because Tambora is right next to the ocean here.
Yeah.
Not only that, it darkened the skies, and people starved to death because for that year they couldn't grow food. So it has a massive, effect, not just in the temperature on a huge grand scale. And so people starve to death and disease spreads.
Yeah.
So a completely different type of volcanic eruption is this ultraplinian one that happened under the ocean, and it blasted the ocean up into the stratosphere. And this is Hunga Tonga. And here is a better visual of that. The reason the explosion is flattening out and rippling is because it hit the stratosphere. And you can see it now being injected laterally into the stratosphere. Because the atmosphere-stratosphere boundary, it's like salad dressing. There is a boundary there. It's physical in the sense there's a density change, and it's very hard to get from one side to the other. So you blast this volcanic eruption up until it hits the stratosphere, and it pushes a bubble up into it, spilling this material laterally into the stratosphere. Where you can see,
it's almost like hitting a ceiling.
Yeah, but it's slightly permeable, and if it's a big enough blast, it gets inside.
Yeah.
And so all of this water vapor was placed in a tiny, tiny moment. And that moment is right here in January of 2022. And all of that moisture is still up in the stratosphere. We're looking at a stratospheric moisture map. And you can see the amount of moisture in the stratosphere has dramatically increased in recorded time. This is the entire recorded history of the moisture in the stratosphere.
Fascinating.
And so this can explain a lot of the major flooding events we're seeing worldwide, everywhere. And they've all seemed to ramp up in the last year. And that's all over the world. And that's because in the last year, the moisture is now evenly distributed from pole to pole.
Mm-hmm.
And prior to that, there was a dry hole in the middle here, which is equatorial and low latitude. So most of the moisture for the first year was very close to the equator. Then it spread to the poles for 2023, and now it is equally distributed with the most around the equator. So we're going to be seeing more flooding for years to come. Just based on this graph, probably it won't normalize till about 2027. What are your thoughts?
That's what I would guess. Yeah.
Yeah.
I was going to say 2026 or 27.
So we've got more flooding to look forward to thanks to Hunga Tonga. Because what happens is the moisture in the stratosphere slowly gets reincorporated down into the atmosphere. It's a process. So you get all these flooding rains and a period of quiescence, and more moisture comes down. Then we got more flooding, and it just keeps happening until we reach the balance where it's supposed to be. We are out of balance right now.
Mm-hmm.
All right, let's look at big picture here. You reminded me last night about this.
Mm-hmm.
The aerosol graph.
Yeah.
And so this is pretty impressive if we want to look back just on the Holocene. Okay.
This data is fantastic in and of itself. It's relatively recent data. This was submitted for publication in 2020, and this is a new set of ice core data.
Yeah.
This is the West Antarctic Ice Sheet Divide Deep Ice Core, WDC.
The WDC.
And it's apparently better ice core data than we've had. What did I just do to my computer? Okay, there we go. It's better ice core data than we've had, partially because I guess it does a better job of looking at the chemical composition of each volcanic eruption in the ice core.
Well, you would imagine that every year we move forward, we're going to have better and better techniques to look at better and better versions of this.
Yeah, yeah.
But the first thing you should glean is that the biggest sulfate spike in recent memory, here we are at 0, is Tambora. And that caused a year without a summer. So clearly this eruption here, which is probably Samalas 1258, much bigger effect. And then we have the European Dark Ages. This is probably some relation to that.
Yeah, yeah.
But come back here. You go back to the Holocene maximum when it was really warm and we were prospering. This must have been a nightmare. These would have darkened the skies for at least several years, and it would have been hell on earth.
Yeah.
And there's 2 right in a row, 500 years apart.
Well, and then the big question would be, I thought I read something about this, whether or not there's a corresponding spike in the Greenland ice core for that time frame, right? Because then we would know that it was something equatorial and certainly had global effects.
Right, because then we're talking VeI 8 here, which is unprecedented.
Yeah.
But look back here. We also have 11,000 years ago, the highest sulfate spike of all the Holocene. Look at it. It's on the ceiling.
Yeah.
It's twice as high as Samalas.
Yeah.
What in good God's name is this? This could be some of the cometary or some of the cosmic. It could even have something to do with the solar outburst.
Mm-hmm.
But that is just astronomically high.
Yeah. Yeah.
But what we should glean, here is a year without a summer, right here. Level. We've got another one here, similar. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 year without a summer, like eruptions, just in this interglacial.
Mm-hmm.
And bad news, look how close they're spaced here.
Mm-hmm.
So the chance of something big happening at any moment is very high.
Yes.
And the paper is pretty awesome. We'll leave you links to this particular paper in full, the comprehensive record of volcanic eruptions in the Holocene from the new Antarctic ice core. Any comments on that?
No, not really. No.
What's also interesting is coming off of the Younger Dryas event, the noise level here is very high. Do you see?
Yeah.
It like ramps down, and then when the big eruptions happen, it kind of ramps up again.
Yeah.
It calms back down. So that is pretty interesting. There is a lasting effect from single eruptions or groups of eruptions that have lasting effects that linger.
Yeah. I mean, it would be really interesting to compare, let's say, indications of like a Miyake event, right, where we're seeing spikes in certain isotopes like beryllium-10 and all of that, which would indicate some kind of event from outside of Earth versus sulfate spikes. Because what I would be interested in seeing is if any of those, like in a Miyake event, has a relationship to the frequency or size of volcanoes, something like that,
As if the sun may be triggering these events.
Right, right.
Yeah, there is so much work to be done.
Yep, yep.
And volcanoes will erupt.
Indeed. There's no stopping that. There's no question about that. I mean, it is also interesting to see that there's not really any discernible pattern here, right? The eruptions appear to be, not on any kind of patterned timescale at all. So we just never know when it's going to happen.
Some of these major eruptions are correlated with grand minima, but
right.
not all of them.
Right.
So there's the wild card factor at any time.
Yes.
I just had a really great thought and it just escaped my mind. Oh, one other thing we can glean from this non-pattern and the fact that there haven't been any VEI 6 or 7 eruptions is because the volcanoes exist in foreign countries that are our enemies, that if we had the ability to make erupt, we would have done that. It makes sense, right?
Yeah.
And we haven't because we can't. There's a lot of people on the internet that think that we can create earthquakes and volcanic eruptions.
Well, yeah, I mean, but, funny enough, I had a similar thought about a completely different topic that actually we're going to discuss about satellites and space junk, right? Like, if we really wanted to, we could take out other countries' satellites very easily and disrupt their communications. And we haven't done that either, right? That we could do. We're just not doing it.
Interesting. Yes.
I mean, I'm not using that to suggest that we have the ability to manipulate weather events and volcanoes, etc. But I mean, the reality is this stuff happens on its own all the time. Right? It's no different. Stuff that has happened in recent history, like the hurricanes in the Southeast, is nothing different than what has been happening forever on Earth. It's not new.
It is not new.
Right.
What is new is all of this junk in space. This is what it looks like today. But these are just the objects that we are tracking, and this is not all of the objects. So low Earth orbit, where Elon Musk's satellites would be, are close to the surface here in this fuzzy array of tens of thousands of satellites. And then we've got further out geostationary satellites. And obviously, look, all these different things way out in space.
Well, and it's more than just the objects that we're tracking. Obviously it's the objects that we're not tracking, but it's also nanomaterials that have been left up there from things disintegrating as they return to the atmosphere, from collisions. There's a lot of aluminum up there.
Yeah, and when that re-enters, it allows people that believe in chemtrails to blame Monsanto on the aluminum in the soil.
Mm-hmm.
When it's actually NASA.
Right. Right. And
So
Starlink, to be fair.
take a look at this Jiffy. And if you're listening on the radio, this is the increase in junk over time, and it rapidly increases into a hellish scenario.
God.
Just a couple pieces there was nothing in 1949. I think one item in space.
Right.
And so just in 70 years, this has occurred, and we've gotten to this. So, and we're exponentially increasing every day, logarithmically. So this is not sustainable in any way. It cannot continue to go on like this because there will be no space.
You know, it just seems so consistent with human nature. You know, we have this tendency to do new things without any like long-term planning with some of the consequences. So we essentially have a big garbage dump up there. You know, not all of this is garbage. A lot of this is stuff that is actually
operational,
still functioning.
mostly. Yeah.
Right. But, you know, the part of the result is that there is garbage up there, and that's the issue, right? Is, you know, if we have too much garbage up there, then we start running out of room to operate because we risk collisions and we risk planes and houses on Earth as things re-enter, and there's been some incidents in that regard.
Yeah, and that leads us to the Kessler syndrome. Now, before I started doing research on this in full force, I had an epiphany when I started researching just space junk. I was like, oh my God, I'll just design a spacecraft that you can put up there and it just vacuums up junk. Like, because we already know where everything good is. You just put all that information in the space vacuum and it just moves around low Earth orbit and encountering things that you need to get rid of. Or it
You
can
need a pretty
identify
big space
something
vacuum
coming.
for that, don't you?
Yeah, absolutely.
Like your storage container is going to be huge.
Yeah, so it needs to be a big ship, but like Elon Musk's hull in one of his rockets is 22 stories high. You could put like 1,000 satellites in there.
Right, right. Well, also interesting,
yeah, and you
too,
got
I
to
saw
bring
that
it back. Obviously, you're going to have hundreds of these up there all the time, re-entering, relaunching, and just cleaning space up.
Yeah. Well, and there's another interesting concept too, like as far as using other space vehicles to remove space junk, right? There's discussion about this in regard to the International Space Station. You know, using another, it's like the Dragon capsule that SpaceX makes for the International Space Station, only much larger as far as engines, and using that to push the International Space Station into the furthest place away from land in the Pacific Ocean, to make sure that when it comes down, it's not going to hit anything. But there's also discussion about other vehicles that, well, building satellites, etc., with like a big magnetic plate so that you have another spaceship that can actually just attach to that and push it where you need it to be.
Yeah, the big issue with towing the space station to low orbit for re-entry is it's gigantic. And we re-entered a space station before, the last one, Skylab, it didn't all burn up and it hit people's houses and it was a nightmare. This is even bigger.
Yeah. So, which is why you have to push it out into the middle of the Pacific Ocean.
Yeah, if that's where it goes.
Well, that's the plan, apparently. So
the biggest problem is there's a long distance for it to transverse before it re-enters, and they have no knowledge of any rogue. I mean, there could be so many rogue pieces that they may encounter on the way. Yeah, so that it's going to be hard to navigate that because we only, there's the known knowns, but there are also the known unknowns.
Yes.
And so the threat there is that the space station could be hit by micrometeorites or rogue debris, and it could be a catastrophe happening on the way to reentry.
So the plan is, so this the helper vehicle is called the USDV, the US deorbit vehicle. That's the vehicle has much more engine power than the Dragon capsules. So it'll dock to the ISS while the crew's still there. And then they're going to allow the space station to deorbit somewhat, right, to lower levels. And then when it gets to 70 kilometers lower than it is now, The crew departs, and then the USDV pushes the ISS towards what's called Point Nemo. That's the point in the Pacific that's furthest away from all land. So that's the idea, is to let it, to let it fully deorbit at that point, and burn through the atmosphere. But there's going to be chunks that don't burn up.
Yes, indeed.
Yeah.
Now, this leads us to the Kessler syndrome. This is a hypothetical scenario where a chain reaction of collisions between satellites in low Earth orbit creates so much debris that space access becomes limited. The term was coined in 1978 by U.S. astrophysicist Donald Kessler, who was still alive 10 years ago. I watched an interview with him. I don't know if he's still around. But the Kessler syndrome could occur as a result of the increasing amount of space debris, which includes non-functional satellites and even flecks of paint. As the number of satellites and debris increases, the likelihood of collisions increases as well. And as we stated earlier, it's just the amount of stuff we're putting up there has exponentially increased in the last 10 years. So
we have a garbage problem in space.
We do. And it's
we
not
have just... I want to make a joke, but maybe I shouldn't.
Right. It's not
similar to a joke that was made recently that sparked a lot of controversy.
I was going to make the same
joke. Although there's no one there to insult, right?
So as the number of satellites and debris increases, the likelihood of collisions increases, and then each collision creates more debris exponentially. 2 things hit and 50 things are now produced. Then those 50 things hit 2 things. It's like whisper down the lane in a nightmare scenario. Mm-hmm. This creates a low Earth orbit belt that we can't ever get through safely. Right. So we would have to create like rockets that are battleships with armor to like pierce through the debris zone.
Yeah. Well, and it's kind of like a domino effect. Like if you imagine, the cascade of dominoes falling, but it's worse than that, because every time one domino hits another one, it creates more small pieces, which creates more cascades. It's not just one line of cascade. It's an infinitely fractaling line of cascading collisions, so it's not good.
Yeah.
And then the more small material that you have up there, the harder it is to remove that stuff.
Right. And what makes it worse is that we have an outer space treaty that states that each state is internationally liable for damage caused by objects that they launch into space. But many people aren't monitoring like we are. It's like, and then who sues them for liability? And what is the
as it says right here,
the liability? You ruin space.
Here too, the treater doesn't explain how liability is determined, right? Like I just saw a picture of solar panels, I think from this ISS, that have, a bunch of impacts on them from space debris. And it's like, was anybody there to witness the piece of space debris that hit the solar panel that somebody's liable for? I mean, that's not happening,
You're right. You'd have to collect.
And how do you know where that piece of debris came from?
You'd have to physically collect it, bring it to Earth, do a forensic analysis to find who owned it.
Right. Like that's not, there's no way that's happening. The more we talk about this, the more I think that your space vacuum idea is really good.
Well, I thought I was going to be the next Elon Musk and a billionaire, but unfortunately, a quick Google and the Pentagon, starting 2 years ago, was looking for garbage collectors in space, and the Swiss were the first to get into it, and inventing of a device here. Mm-hmm. It says Europe is at the forefront of this cleanup. Since May 2018, the agency has been testing various solutions as part of its Remove Debris mission, and the most promising of which is the Swiss ESA team. Mm. And of course, here, Australia got into it last year with a space sweeper designed to vacuum up satellite debris. And it kind of just has a big opening and a big area to store stuff as it comes in. Probably some huge magnets to slow the object down and to stick it in the back,
You know what's interesting about the vacuum idea when you think about it, I mean, as you go up in altitude, there's less and less material in space. And so, a vacuum by comparison is going to be relatively less and less strong, the less material there is in space, right? So that's kind of interesting to think about. Like, how do you create that negative pressure to actually vacuum up objects when it's going to get harder and harder and harder to create that negative pressure, which is interesting.
Well, you could have a grabber, like a
Right.
salamander tongue, that shoots out and grabs the object and sucks it in.
Yeah. Well, the best
But you
candidate
could
for
also, I was also thinking of it like a net. So this is now moving through space with some speed forward, and stuff just goes through and gets caught in the back.
right. The best the best person probably to develop this is probably Elon Musk. I mean, if he can catch essentially a 20-story skyscraper
Well, this
coming
is
down.
Elon Musk's conceptual design.
Oh,
right
it
here.
is.
So he
Okay.
is involved.
Okay, yeah.
And it's based on the lizard tongue. So this is a chameleon-like tongue that shoots out of the spacecraft like it's sticky and grabs the object and sucks it back into the hull.
Yeah. Well, and Musk really should be involved with this, right? Because honestly, a big contributor to the space debris is Starlink. So we talked about this on another show maybe 6 months ago or something, about the amount of material that is being left up in low Earth orbit, partially as a result, because these satellites, the Starlink satellites, are really only designed to be good for like 5 years, right? And they're designed to fall back to Earth when they fail. But so here's some
and to completely burn up. So he's really not
Right.
contributing to the problem. The only thing that's space junk is his Tesla that he shot into far Earth orbit.
Well, no, that right.
I think
But
that
that's not
Tesla's actually headed towards Mars.
Wow.
And it's going to re-enter on Mars based on the trajectory. So there'll be a Tesla on the surface of Mars at some point.
But it's not true that Starlink isn't contributing, because it is contributing in the sense that it is leaving a lot of aluminum oxide in the atmosphere, and there is some concern about how that may affect the ozone layer as well as our magnetic field. So
he's not leaving junk in space. He's leaving junk in our atmosphere.
Well, right. So this is, yes. Yeah. Thank you for that correction. Just some stats on that. And this is not just Starlink, this is all satellites. But in 2022, re-entering satellites increased aluminum in the atmosphere by 29.5% over natural levels. Also interesting that it's estimated that by the time the currently planned satellite constellations, so there's a lot more Starlink satellite constellations planned to go up, but that is also true of satellite constellations from companies like Iridium, which makes satellite does satellite communications like sat phones and stuff. They're much higher orbit, but they still contribute in this respect. So by the time all of the planned constellations are up there, every year, 912 metric tons of aluminum will fall to Earth. That will release around 360 metric tons of aluminum oxides per year to the atmosphere, which is an increase of 646% over natural levels. That's a lot of aluminum.
It's that's capitalism there. We just keep going and going and going until we're like, oh, we just destroyed it.
Right. Or like, oh, the landfill's full. What do we do now? I mean, this is what we've been doing as human beings in industrial society for quite some time.
Right. It is very clear that we cannot continue to move forward at this accelerated pace of added space junk, which is designed to burn up in our atmosphere in just a few years. It's kind of like the windmill dilemma. In order to build a windmill that makes electricity, it costs millions in government subsidies to build one, and the windmill can never produce enough energy to even pay for the construction.
Right.
Not even close. And then in a short period of time, it's useless, it's burned up, It's chopped up birds, and then we have nowhere to put it and no way to recycle it. It's a complete fairy tale nightmare. And all of the policy is being driven towards plant food. It's absolutely insane.
Yeah. Well, and like, you know, in the windmill example, no matter how you look at it, there's the additional cost of that garbage, the fiberglass blades that you can never recycle or will never break down. You know, but either way, it costs you something. Either you figure out a way to clean it up, and that's going to cost money, or it's just going to sit there and pollute. I don't know, a while ago, I was really excited one day because I saw this video that was about quote unquote recycling windmill blades. And I was like, oh, yay, how are they going to do that? And then I watched the video, and in the end, all they do is burn the fiberglass. Doesn't make any sense.
Well, they are finding ways. They're making these manufacturing plants that are crushers that can crush up the fiberglass, and they're adding it to concrete. So I think that
why can't you crush it up and like reuse it for fiberglass insulation or things like that? I mean, we have so many other uses for fiberglasses in the world. I mean, I'm sure there's some
develop the industry that does that. That's the point.
Right. Right.
Reason we don't have hemp fabric and hemp paper is because we don't have a hemp processing industry in the United States.
Here's a very interesting factoid. Styrofoam can be literally dissolved using limonene, which is from citrus peels typically. It's in other things. It's in cannabis, for example. Very simple process. The problem is, again, we don't have the infrastructure or the industry to take care of that. And so all of our styrofoam just sits there in landfills. It's stupid.
Yeah, you can just get a cup of gasoline and you could put 1,000 styrofoam cups in there and it'll just melt.
Right.
And then you made your own napalm.
Right.
I wonder if the government's going to come after us now. If you're listening out there in Radio Land, this will not play tonight on Magnetic Reversal News because we've gotten a strike for our election night live stream for medical misinformation. So this will instead be up on Oppenheimer Ranch Project, 8 p.m. Mountain Time.
Okay.
Did you know that? I wanted to get that out there.
No, I didn't know that. I know now.
So we definitely need to have some, it's only been 2 years, really. It started in 2018, but only countries in the last few years have started to experiment with space junk collection. And I believe in the next decade, we're going to have a lot of this going on, especially if a company like SpaceX finds a way to make a grabber here. Let's say you could grab a piece of, do you know how much gold and platinum and stuff are on these pieces of junk?
Well, and that's promising, right?
Just bring them home and you've got $500,000 worth of stuff.
Yeah, financially, there's a big incentive to do that. I mean, I don't know what the costs of collecting the material versus the value of the material is. That would be the big question.
Well, initially, there'll just be some kind of an offset. But if you master it, it's definitely going to be profitable.
Yeah.
I mean, we've all seen like Star Wars and Battlestar Galactica. They're professional space junkers.
Yeah.
I've watched it.
That tells the future. TV tells the future. Sometimes it does. Simpsons tells the future correctly sometimes.
Yeah, and if the Pentagon is looking for garbage collectors in space, there must be money involved, as well as national security threats.
Yeah.
So what are your any other thoughts on the Kessler syndrome?
I mean, just that it's very predictable as far as human nature to sort of get ourselves into this bind where we create all of this waste material and we never developed any plan in the beginning to deal with the waste material. It's so typical. I don't know if it's human nature or not. I mean, it's certainly a characteristic of industrial society, right?
Yeah, I believe that in the near future, the technology will increase so rapidly that there will be some type of a quantum machine that we can put into space that can vaporize things. You know, not blast them with a laser into a million pieces, but literally evaporate them somehow using high energy electric fields or something like that.
I mean, that won't solve the problem of, let's say, like nanomaterials sitting up there in space and potentially causing a problem with our magnetic field.
Yeah, there would have to be also some type of, so we have remediation measures on Earth. Let's say there's a huge toxic plume of PCB in the aquifer. We set up these giant pumps. We bring up all the water from the aquifer continuously. They run 24 hours a day and they keep pumping it back in and they keep filtering it out with a HEPA filter. This goes on for years and the levels keep coming down lower and lower. So we'll have to have some type of space vacuums, just like I said, doing this.
Yeah, I mean,
and they might be, because of the technology, think about it. They could be chemical factories collecting and processing all these particles. And then they, fill up storage containers of materials that get then sent back to Earth as raw materials.
Mm-hmm.
Yeah.
I think the big challenge would just be dealing with the sheer volume of space that you would have to like filter, vacuum up and filter. I mean, considering when you think about it, just in dealing with like the example that you proposed for PCBs and filtering that out of waterways, even that is a monumental task. And the volume that we're talking about, in orbits around Earth is going to be enormous.
Right. So you really have to expand your mind and think about a craft that is kilometers across.
Yeah.
That's the future.
Yeah. Yeah.
That is the only way it's even feasibly possible because of what you just said about the aquifer scrubbing. It's a tiny fraction of the surface of the Earth, and it takes a huge amount of work.
Yeah.
So you really would have to scale this up. Someone like Elon Musk, I'm sure, is already thinking about that.
Sure.
And these would be enormous spacecraft, which I think in a decade or so, we're absolutely going to have enormous spacecraft up near the moon, near Mars, or just out in space as a scientific station.
Mm-hmm.
Because the reason they're re-entering that space station, the ISS, is it's so antiquated. I mean, I can't, it's so old. It's like it's like the first computer that we ever had, the Commodore 64. That's what's up in space, and they're finally re-entering it. We could have a smartphone up there. It's not up there yet. It's amazing how behind the technology is that we're using in space. I mean, the ISS leaks in like 14 places, has been leaking for decades. They can't find the leak. I mean, it's a tin can. It's crazy.
I mean, can you imagine how, I mean, obviously for a regular person, much more so, but how terrifying it was to be stuck up there for months?
Yeah. Well, there's 2 astronauts still up there from the Boeing craft.
Right, but they stayed on purpose, didn't they?
They had to, because it's all protocol. There were other people on the ISS have to leave before them because they're already on a flight. You know what I'm saying?
Right, right.
So they have to stay
what's really
until next
funny?
year. Next year, Elon's going to go save them.
Right. Just a funny side note. A couple weeks ago, I just Googled about those astronauts that have been stuck up there because I hadn't been following the news on it. And I really hate that every Google search, the results all start with an AI responding to you, right? Because more and more people are going to be relying on the answers from the AI as the truth. Anyway, that's another side note. But the AI responded in past tense that the astronauts were rescued in early 2025. Which was hilarious because they had already been rescued. I mean, that was obviously the plan, was to get them by early 2025. It ended up happening sooner than that. And then here's the AI responding as if it's 2026 and that we rescued them in early 2025. And I was like, this is so bizarre. Is the AI like on another timeline? Like, what's happening there?
Those astronauts have not been rescued yet. They're still up there.
I thought they had.
No, they're coming back in next year in February of 2025. There are 4 astronauts that came off the ISS were up there for a year already. They had to come home. And
I know.
They all went to the hospital. So something is going on up there.
Yeah. Yeah.
Yeah.
Well, that's what I'm referring to. I'm referring to the astronauts that did come back that had been stuck there and are not stuck there anymore.
No, those astronauts were not stuck there. They were up at the ISS for a year and they were scheduled to come home. The Boeing astronauts were not supposed to be there, are still there.
Okay.
Yes. The 2 people that went up on Boeing are still there until February.
Okay.
Because they
But
couldn't they couldn't take the spot of the other astronauts who have been up there for a year. They had to get off.
yeah.
And say, no, you guys can stay up a couple more months. We got food.
Yeah, but nonetheless, according to AI, they were rescued. They were past tense rescued in early 2025.
Well, hopefully they will be, but anything can happen, right?
Yeah.
Right. Because the thing is leaking.
Yeah. Well, and then I don't even know, do we have another plan for like another ISS? Or are we just not going to have a space station anymore?
They would have to make one, I think, between now and then.
Yeah.
What was the reentry date? 2029? Or is it 2026?
It's I think it's 2026. Hang on. Oh, 2031.
Okay, so they got plenty of time.
Yeah.
They got 7 years to rebuild the new space station.
Yeah. Which is funny because I heard Elon Musk say the other day that it's or no, I don't think he said it the other day. Somebody was paraphrasing him saying this at some point, that it took more time to fulfill all of the regulatory documents for a 20-story rocket than it did to actually build the rocket. So we'll see if we actually manage to build another space station in that time frame.
And get it up there through all this garbage.
Yeah.
So here's
and that's the thing, is the garbage, the amount of garbage is the rate of increase is probably exponential now.
Right. And the leaks on the space station are because it's being bombarded for 2 decades by micrometeorites and tiny little pieces of flecks of paint, and they can't locate the leaks because they're microscopic, and there's probably thousands of them.
Right.
And here's the worst case scenario. We have a Miyake event or a Carrington times 10, and then we lose control of monitoring this debris. The odds of a Kessler syndrome occurring, a cascading failure, is 100% at that time.
Yes.
Because the event itself is going to move some of these out of their orbit. There will be collisions. They will explode from the power of the plasma. Some of these craft will just blow up.
Yeah.
And then it will all re-enter on Earth. So literally all this garbage will pollute the atmosphere in like a grid down Stone Age nightmare scenario.
That would be absolutely apocalyptic. I mean, we'd have no ability to control anything that's up there or its descent. It would be a total, and the domino effect that I described earlier, that's not just one line of dominoes, but a whole series of other trails of colliding dominoes outside of that. I mean, it would be an immense apocalypse.
Right. The aluminum and all the isotopes up in the stratosphere and atmosphere, destroying the ozone, and God knows what it would do to climate. It would be a mass extinction event in a sense, but so would the grid down scenario.
Yeah. Well, and the other interesting thing about it would be, you've got the grid down scenario and then you've got stuff falling to Earth, but the stuff falling to Earth isn't all going to happen all at once, right? That's going to take a period of time for all of those collisions to happen and all of that stuff to re-enter. So it would be ongoing for quite some time.
Yeah, and what's interesting to think about is that the Miyake events in the past, there's no evidence of it affecting humanity because they were living without electricity, so nothing happened. Let that sink in.
It's our own fault. We do it to ourselves. Oh.
Pray to God, but swim the shore.
Yeah. I mean, it's hard not to think that, pray to God, but swim to the shore. Row to shore. It's row to shore. Pray to God, but row to the shore. Shoot, I forgot what I was going to say.
Great show.
The bumper just saved me. Well, find us tonight on Oppenheimer Ranch Project on YouTube at 8 p.m. Mountain Time.
We love you.
Listen to Revolution Radio at freedomslopes.com. And we'll be right back after this message.